For the past few years, we've all been blown away by AI that can talk. But what if the next giant leap isn't about mastering words at all, but about understanding entire worlds? So today, we're going to dive into a game-changing concept called world models. And it all kicks off with one very high-stakes question.
No, seriously, how do you do it? That ball travels from the pitcher's mound to home plate in less than half a second. By the time the image of the ball even hits your retina and gets processed by your brain, it's already moved several feet. So if you can't possibly react to what you see, how in the world do you hit it?
And that, right there, is the secret. You don't swing at where the ball is. You swing at where your brain calculates it is going to be. This isn't just some cool sports trick. It's absolutely fundamental to how we navigate reality every single second. Okay, so if we really want to get a handle on this new kind of AI, we have to start with the original, the incredible simulation engine that's already running inside our own heads.
Get this, 200 milliseconds. That's roughly how long it takes for a visual signal to travel from your eyes to your brain and be processed into something you consciously see. In the world of a 100-mile-per-hour fastball, 200 milliseconds is an absolute eternity. It means that what you perceive as the present is actually always in the past. Your entire experience is really just a prediction.
And this is what scientists call a world model. It's your brain's gut feeling for physics. It's the part of you that just knows a dropped glass is going to shatter, that a thrown ball will follow a curve, and that you can't just walk through a solid wall. It's like a little physics engine in your mind, constantly simulating what's about to happen next. So, what happens when we give that same superpower to a machine? All right, let's make the jump. How does this idea translate from our brains to an artificial one? This is where we see the crucial shift from an AI that just sounds smart to one that can actually act smart in the real physical world. Okay, this slide really breaks it down. A large language model, like ChatGPT, is a master of language. It knows the word gravity often shows up in sentences about falling apples. But an AI with a world model, it understands the concept of gravity. It predicts that if it sees an apple floating in a video, the very next thing that's going to happen is it's going to fall. It's the difference between a brilliant parrot that can just repeat phrases it's heard and an actual engine that can simulate cause and effect. A huge difference. So how on earth does a machine actually build this internal world? Well, researchers have basically broken it down into 3 core components that all work together. And they're actually a bit like our own brain and senses. First up, you've got vision. Think of it as the eyes. The AI looks at a super complex scene, like a busy street, and squishes it down into a simple summary, something called latent space. It just grabs the important stuff. Car there, red light ahead. Second, you've got memory. This is the simulator. This part takes that little summary and just dreams about the future. It asks, okay, if I turn the wheel left, what happens next? It runs a tiny simulation. And finally, the controller, the hands. This part is pretty straightforward. It just looks at all the different dreams from the memory and picks the one that leads to the best possible future. And look, this is not some far-off sci-fi theory. This technology is the secret sauce behind some of the most advanced, mind-blowing AI systems that are being used right now. I mean, just think about self-driving cars. You can't have them learn by actually crashing in the real world, right? That would be a catastrophe. So instead, they use world models to rehearse disaster. They can simulate a kid running into the road 1,000 times in just a few minutes, learning the safest possible response without ever putting anyone in real danger. Or how about robotics? Trying to teach a robot to do something as tricky as folding a t-shirt used to take forever. But now, a robot can just dream about the physics of fabric all night long, running simulations that are 1,000 times faster than reality. It shows up to work in the morning having already put in years of practice. And this explains exactly why AI-generated video is getting so freakishly realistic. The early stuff was a total mess because the AI had no physical intuition. But now, models like Sora use an internal world model. They understand object permanence, the basic rule that if a person walks behind a building, they should eventually pop out the other side, not just vanish or randomly turn into a flock of birds. Okay, but let's get real for a second. As with any massive technological leap, building these digital dreams is incredibly, incredibly hard. There are some major hurdles the entire field is trying to get over right now. So here's a really big debate, and it comes from an absolute giant in the field, Yann LeCun. He argues that just watching videos isn't enough. He's basically asking, to really get the world, does an AI need a body?
Does it need to be able to push things, to feel resistance, to see what actually happens? This is one of the biggest questions in AI today.
And beyond that big debate, you've got some serious, real-world problems. First, the sheer power needed. Simulating reality, even a simple version, takes a ridiculous amount of energy and crazy expensive computer chips. Then there's the hallucination problem. But here, the AI isn't making up facts, it's making up physics, like forgetting a wall is solid, which you can imagine would be a disaster in a self-driving car. And finally, data. The internet is flooded with text, but high-quality video of physical interactions, there's just way, way less of that for an AI to learn from. So even with all those massive challenges, why is every single major tech company pouring billions of dollars into solving this? Well, it's because this technology is, without a doubt, the next great frontier for artificial intelligence. And this, right here, is the most important thing to remember. For years, we've been focused on teaching AI to be a better conversationalist. Now, we're teaching it to be a better physicist. This is the bridge from a digital assistant that can write an email for you to a physical partner that can help in a kitchen, assist in a surgery, or even explore another planet. Okay, before we finish up, let's do a super quick recap of the key terms. Latent space, remember, that's the compressed shorthand summary of a scene. Embodied AI, that's just an AI with a physical body, like a robot. And physics aware, that's the end goal, an AI that truly gets the rules of our world. And all of this leaves us with one last kind of mind-bending question to chew on. We are actively teaching machines to build these internal simulations of our world. As those simulations get better and better, more and more accurate, what happens when a machine's dream of reality becomes indistinguishable from reality itself? That's something to think about.